Okay, let's start our lesson today. Today we will go over 6.5, 6.6, and 7.1 a little bit. I'm not feeling that well today. For some strange reason, I could not sleep last night. I slept like around 5:30 in the morning. I don't know what happened. So I feel like I'm about to catch some cold. So forgive me if I make mistakes, a lot of mistakes today. I don't think so. I'm very alert. That's the thing. I'm very alert. Just my body aches, and then my voice starts to change. Anyway, in this 6.5, we will see two groups. Group 4, product to sum, and group 5 later on, sum to product. The proof you can see in my lecture video, but the core or the underlying formulas, the underlying ideas for the proof actually come from the following. For example, the proof for 1. We will do the extension or the expansion of cosine A plus B, which is cosine A, cosine B, minus sine A, sine B. Now notice that we have the same expansion with different sign in the middle for cosine A minus B. So the same terms, but addition in between. Now what happened is then when I add this, when we add this, the one has opposite sign will cancel, right? The one that has opposite signs will cancel. So we end up with 2 cosine A cosine B. While on the left-hand side, we have cosine sum plus cosine difference. Therefore, then, if we divide by 2, we will get 1/2 of cosine sum plus cosine difference equals to cosine A cosine B. Now, if we subtract instead, then we will have cosine A plus B minus cosine A minus B. Now the one with same terms will cancel instead if we subtract, right? Okay, and then, so this will cancel. This becomes -2 sine A sine B. Now dividing both sides by -2, we will get -1/2 of cosine A plus B minus cosine A minus B equals to sine A sine B. So this is actually the proof for 4.1 and 4.2. Now the proof for 4.3 and 4.4, you actually get the expansion of this guy, get the expansion of this guy. If you add them, you will get 2 sine A cosine B. So to isolate sine A cosine B, we divide by 2 both sides after that. Okay, so that's the idea of the proof. Okay, now for sum to product formulas, group 5, Let me write them out first. I usually in the regular class, I did not require them to memorize this. So I will not require you to memorize this also. Okay, at the back of your test 4 later on, you will see these two formulas. Of course, if you can memorize it, that will be the best, right? But if you cannot, at least you practice, you learn how to use them. These are the formulas. And the proof, actually because of substitution. Okay, now notice that the proof, you will see the proof for 1 here actually coming from 4, 1. The proof of 5, 1 comes from 4, 1. The proof for 5, 2 comes from 4, 2, and so on and so forth. Okay, and the proof is actually because of the substitution. What happened is, suppose we are given cosine, sum of cosine instead. So cosine x plus cosine y. Okay, then what will that equals to? We will multiply both sides by 2, so we will get 2 cosine something, cosine something. Now, but let's first do that substitution. Let x be a plus b and y be a minus b. So you see that we have this kind of thing again, right? When we add, we get x plus y equals to 2a. So a equals to x plus y over 2. So in this formula here, okay, we will substitute a plus b as x. This guy becomes x. Okay, now what happens if we subtract? If we subtract, we will get x minus y equals to 2b. So b will be x minus y over 2. So if I substitute a minus b becomes y, then a will be x plus y over 2. The b will be x minus y over 2. Okay, so now the full proof, I believe in my lecture video, you try to prove it yourself, okay, using this idea. So you grab, after you do this substitution here, okay, after you get this substitution here, you rewrite one of the formula, let's say formula number 4, right? Let's say formula number 4, 5, 4, we have cosine A sine B equals to 1/2 of sine sum minus sine difference. So at least you know what actually happened in between. Multiply both sides by 2. Then do the substitution. So sine A plus B, that becomes sine X. A minus B becomes Y. Now, if you do such substitution, then A becomes X plus Y over 2, and the B becomes X minus Y over 2. But that's exactly what you see in formula 5.4. Okay, now if you ask me, I do memorize this formula though, both of these groups here. I memorize these formulas, not only because I get used to it, but because I remember how to prove it. Okay, so I can easily recall these formulas by knowing what actually happens to them. Now, with that said, then let's start working on problems in our textbook. Let's see number 3, for example. Express as sum or difference. Number 3, cosine 6u cosine negative 4u. Cosine times cosine is equals to 1/2 cosine of sum plus cosine of difference. That is 1/2 cosine 2u plus 1/2 cosine 10u. That's it. Number 7. Number 7. 3 cosine x sine 2x. This is equals to 3 times 1/2. This is formula 4.4, right? This is formula 4.4. This is 4.1. So cosine x sine 2x will be sine of sum minus sine of difference. So this is 3/2 of sine 3x minus sine negative x. Oh, but sine negative x is negative sine x, right? So this is 3/2 sine 3x. Negative becomes plus, and I distribute that 3/2. Okay, that's for number 7. Number 11. Cosine 5x minus cosine 3x. This is formula 5.2. Cosine minus cosine. That is negative 2 sine of sum over 2. Hold on. Times sine difference over 2. Use the formula first. Don't compute right away. Don't compute right away. Okay, so I use the formula first, and then after that, in the next step, I compute 8x divided by 2, that's 4x. 2x divided by 2, that's x. Done. Done, right? Number 13. I randomly pick questions, by the way. So if sometime later on, or if you suddenly see a question you want me to go over, just let me know. Sine minus sine is -2 cosine of sum divided by 2 sine difference, it's a t, not x, divided by 2. So that's -2 cosine 6t sine -6 divided by 2, -3t. Hold on. No, I don't need negative. I don't need negative. I don't need negative. Sine minus sine. The way I think is this: sine minus sine, then the later part. So they are the sine will give you sine cosine, right? Cosine sine. So sine cosine cosine sine. So when you subtract, okay, when you subtract, then the first term cancel, give you 2 cosine sine, 2 cosine sine. Okay. So I kind of like, instead of memorizing the formula, I memorize how I get that formulas. Okay, of course, you can look back to the formula all the time, right? You have open notes anyway. Sine negative is negative sign. So let me pull the 2 negative to the front. Number 17. That's proving. Proof sine 4t plus sine 6t over cosine 4t minus cosine 6t equals to cotangent t. Proof. I will start from left-hand side. Equals to sine 4t plus sine 6t over cosine 4t minus cosine 6t. Don't do any computation for here. Now then I will use the formulas I know. Sine plus sine will be, sine plus sine will be 2 times sine sum over 2 cosine difference over 2. While cosine minus cosine is -2 sine sum over 2 sine difference over 2. Then simplify on the top, I get 2 sine 5t cosine negative t. At the bottom, I have negative 2 sine 5t sine negative t. Well, I can cancel the 2 and the sine 5t, right? Okay, so I have cosine negative t over negative sine t. And then using the negative angle identities, cosine negative is cosine positive. Sine negative is negative sine positive. So at the bottom, it becomes just sine t. But that is what we have on the right-hand side. That's called tangent t. Okay, that's for number 17. Number 23 seems to be quite interesting. Let's see, number 23. Proof for cosine x cosine 2x sine 3x equals to sine 2x plus sine 4x plus sine 6x. You know what? Let me bring it down so that it's better visibility. Okay, so the proof will be, I don't even know which one is more complicated, but let me just do it from left to right. Proof from left to right, that's left-hand side, equals to 4 cosine x cosine 2x sine 3x. This is equal to cosine cosine, that's 4 times 1/2. I will do this first. I'll do the cosine cosine first. I'll do this first. Okay, so that will becomes 1/2 of cosine sum plus cosine difference. Right? Now 2 and 4 becomes 1/2 and 4 becomes 2. This is cosine 3x plus cosine negative x sine 3x. But cosine negative x is cosine x. So this is 2 sine 3x. I write the sine 3x first. Now cosine 3x plus cosine x. Is it okay? Then I will distribute 2 sine 3x cosine 3x plus 2 sine 3x cosine x. Oh, okay. Well then, 2 sine x cos 2 sine 3x cosine 3x. That's just double angle for sine, right? That's sine of 2 times 3x. Is that right? That's double angle formula. That's formula 2, 2. Okay, plus now 2 sine 3x cosine 3x. That will be, so this guy here, I will extend this now using product to sum. That's formula 4, 3. Okay, that will be 2 times 1/2 times sine sum plus sine difference. That is sine 6x plus sine 4x plus sine 2x. Let me rearrange the ordering so that it match with what we have on the right hand side. Like commutative property, right? Addition is commutative. That's what we have on the right hand side. Okay, but by the way, I will need you to realize that this proof is not unique though. I have a very strong feeling that you will get the same result if you had combined the last 2 terms first. Okay, so you will get 4, later on you will have 4 cosine x, and then times 1/2 sine sum minus sine difference. Okay, then you get 2 cosine x times sine 5x plus sine x. And then you distribute. And this will give you 2 terms. But this is double angle formula, 2 sine x cosine x. Okay, so in other words, the way I did it is not unique. It's not unique. Okay, it's not unique. Yeah, you may do it in different order and still get the same result. The one I think also possible, instead of you do from left to right, you may want to try doing it from right to left. Okay, now how about solving using these formulas into solving equations? Let's say we do number 29, the easy one first, number 29. Then we have cosine x equals to cosine 3x. Solution. I set one side equals to 0. The idea is I set one side equals to 0. And the right hand side we have cosine, difference of cosines. Now the thing is, using formula for 2, you make it become product, right? Sum becomes product. So this is negative 1/2. I'm sorry, not negative 1/2, 2 times. That's 2 times negative 2 sine sum over 2 sine difference over 2. which is -2 sine 2x sine x. So either sine 2x equals to 0 or sine x equals to 0. Then from there we see if sine 2x equals to 0, then 2x will be pi k, right? So x is pi k over 2. Sine x equals to 0 means x equals to pi k. Now the thing is, this solution here is part of that one. Think about it. If I list them, right? If I list them, I will get x equals to 0, pi, 2 pi, 3 pi, and on with plus minus, right? While the one here will be 0 pi over 2 pi, 3 pi over 2, 2 pi with the plus minus. You see? So you see that the solutions from the right branch are part of the solution on the left branch. Therefore, we can just condense them into the solution on the left branch. So x equals to pi k over 2 for k, any integer. Number 31. You know what? Let me move this a little bit to the left so that I can save some space on the right hand side. Number 31. Solve cosine 3x plus cosine 5x equals to cosine x. What I will do, I will combine the one on the left first. That will be 2 cosine sum over 2 cosine difference over 2. So that's 2 cosine 4x cosine negative x equals to cosine x. But cosine negative x is just cosine x. Now then, I set one side equals to 0. Never divide by any expression that possibly 0, unless you are aware that it is possibly 0. Okay, but the correct way of showing the work is actually this way. Okay, and then I factor cosine x, right? So I get 2 cosine 4x minus 1 equals to 0. So cosine x equals to 0, or cosine 4x equals to 1/2. Now cosine x equals to 0, x equals to pi over 2 plus pi k. Okay, now cosine 4x equals to 1/2. Either 4x is 60 degrees, that's pi over 3 plus 2 pi k, or 300 degrees, 5 pi over 3 plus 2 pi k. Now then we divide by 4. Okay, and we divide by 4. So x equals to pi over 12 plus pi k over 2 5 pi over 12 plus pi k over 2. So the solutions are this guy and this guy together. Okay, for k any integers. Okay, now that's for 6.5 suggested homework from here. So this section is actually not long, but just applying formulas. 6.5 from number 1 to number 33. And I think you can just do every other odd instead of all odds. Every other odd is good enough. Okay. That's for 6.5. Now, 6.6 is where it gets heavy. Inverse trick. Again, I still assume that you have watched my lecture videos. Okay, since 0.6 inverse trick. And the focus of our discussion here is to go over problems. The theoretical foundation was laid down in the lecture video. Now, I will still go over a little bit the theoretical foundation, but it will be fast. Now, what happened is this. Trig functions are periodicals. Now, what happened then? It means trig functions are not one-to-one. So it is not possible to create inverse trig function without doing something to make them one-to-one first. You see? Okay, because they are not one-to-one, right? Okay, they are not one-to-one. So one way to make them one-to-one is to restrict the domain. Okay, to make them one-to-one, and we learned this in actually, I think in test 1, right? In test 1, we learned you have some functions which is not one-to-one, but you make it one-to-one by restricting the domain. For example, when we have fx equals to, I don't remember precisely the question, but fx equals to, let's say, negative x minus 3 squared. Now, this is not a one-to-one function, but if we restrict the domain to, let's say, x less than 3, then it becomes a one-to-one function. Then we can find the inverse, right? So y equals to negative x minus 3 squared for x less than equals to 3. We swap the x and y. So negative x, put the square root with plus minus equals to y minus 3 for y less than equals to 3. So 3 plus minus square root of negative x equals to y for y less than equals to 3. Oh, from there we realize, oh, we will use the negative branch. Okay, so the inverse function is 3 minus square root of negative x. So that's one example where if we have not one-to-one function, but we want to find the inverse function, okay, and we need to make it one-to-one first. And one way to do it is to restrict the domain. Okay, so that's an example we have from the past, right? Okay, this is not one-to-one. becomes 1-to-1 because we restrict the domain. Now, to make them 1-to-1 discrete functions, then by convention, y equals to sine x is restricted to negative pi over 2 to pi over 2. Okay, now some teachers say that's quadrant 1 and quadrant 4. I prefer to say that's quadrant -1 to quadrant 1. Okay, so the region for the restricted domain will be in quadrant -1 and quadrant 1. If we take a look on the graph of sine, y equals to sine x, the graph of sine x looks like this, right? And here you copy paste like that, right? Now then the domain is restricted from negative pi over 2 to pi over 2. This is the window. Okay, that's the window. Notice that in this window, the sine is 1-to-1. Okay, so what happened is our mathematical predecessors actually needs to choose which window to use such that we have a 1-to-1 function for sine x, right? Now, of course, they have a lot of options, right? Okay, but they then decide to use this window. Okay, one of the main reason is because, well, they want a window that is continuous, like instead of separated window, let's say they want, oh, you know what, let's use this one here and then this one here. Can they do that? They could, but they don't want to. Why? It's separated. Okay, they don't want the separated intervals, so they want a good interval like this. And on the other hand, another reason why they chose this one is because they can actually make use of the fact that sine x is an odd function. Sine x is an odd function later on, then the inverse sine will also be an odd function. Okay, that's the benefit. That's the benefit of using this interval. Okay, so for example, what is sine sine inverse of 1/2? Sine inverse of 1/2. What is the angle? It has to be in radian actually, right? What is the angle such that sine of that angle is 1/2? That's pi over 6, right? There are actually two angles that give you 1/2. Sine pi over 6, that's equals to 1/2. Sine 5 pi over 6 also give you 1/2. But the problem is only pi over 6 in that window. Okay, only pi over 6 in that window. Okay, but only pi over 6 in that window. So you need to choose an angle that is in that window, okay, in quadrant -1 and quadrant 1. Now remember I said earlier about sine inverse is therefore also an odd function. Then sine inverse of -1/2 is equal to negative pi over 6. In fact, we can say for sine inverse negative x, sine inverse negative x is equals to negative sine inverse x. Okay. Now that's for sine inverse. Another one, the tangent. Y equals to tangent x is not 1-to-1, but then restricted to negative pi over 2 to pi over 2 also. To take advantage of the fact that sine is also an odd function. I'm sorry, tangent is an odd function. So if you take a look on the graph of tangent, the graph of tangent looks like it's periodical, right? The graph of tangent is periodical. It looks like this. And then you have that again here. And you have that here. Okay, now, so they want a window that is continuous and, if possible, take advantage of that, the fact that tangent is an odd function. That's why they choose this window here. Okay, that's why they choose this window from negative pi over 2 to pi over 2, but not including the endpoints, not including the endpoints. Okay, because at pi over 2, tangent pi over 2 is undefined. Tangent negative pi over 2 is also undefined. Okay, so they choose that window. Now, if you look at the unit circle, the position, again, the same to sine. It is in quadrant 1 or quadrant -1. Okay, so for example, what is tangent inverse of radical 3? Tangent, what angle is radical 3? That's pi over 3, and 4 pi over 3, that gives you radical 3, right? But only pi over 3 in that window. Okay, so tangent pi over 3 is radical 3. Tangent 4 pi over 3 is also radical 3. But only pi over 3 in that window. So you need to be very aware of the restricted domain. Okay, now the good news is, since tangent is an odd function and they purposely use that kind of window, then we can make use of the fact that tangent inverse, therefore, will also be an odd function. Okay, basically, tangent inverse of negative x is equals to negative tangent inverse of x. Okay. Now, how about cosine? Y equals to cosine x is restricted to quadrant 1 and quadrant 2. Okay, if we take a look on the graph of cosine, it is an even function. Okay, so we cannot get a symmetric window around the origin. No, because if you make this window here, it's not one-to-one, right? So then what they do is they choose the best, in their opinion, the best window is from 0 to pi. Okay, that's the best window. Now, if you imagine the graph on the unit circle, then the restriction is actually in quadrant 1 and quadrant 2. Okay, quadrant 1 and quadrant 2. Now, for example, how about cosine inverse of 1/2? That's pi over 3. It's actually pi over 3 and 5 pi over 3, but only 5 pi over 3 in this window. Okay, now the thing is, what happens if we have negative inside the cosine inverse of negative 1/2? Okay, now let's do it traditional way first. So let's answer this question. Cosine what give us negative 1/2? Cosine is negative in quadrant 2 and quadrant 3. The reference angle is pi over 3. So this must be 2 pi over 3 or 4 pi over 3. Okay, now which of these two is in that window? But only 2 pi over 3 is in that window. Okay, so the answer is 2 pi over 3. Can we do this using reference angle idea, Thomas? Yes, in fact, you see that they have the same reference angle. So this guy and this guy have the same reference angle, but this is in quadrant 2. Right? Okay, so one way to look at that is, we can see it this way. The cosine inverse of negative 1/2 is pi minus the angle in quadrant 1. Cosine inverse of 1/2. Okay, and that gives us how to deal with negative value inside the cosine inverse. Cosine inverse of negative x is the supplement of cosine inverse of positive x. Okay. Now, there is no convention, note, there is no convention for secant inverse, cosecant inverse, and cotangent inverse. Now, our textbook actually gave us on page 470, right? They give us the restricted domain, but there is actually no restricted convention for restricted domain. I think I need to say for cotangent inverse x, there's a convention for that. I'm sorry. For secant cosecant, there's no convention. So what our textbook doing? Our textbook uses the restricted domain that are not by convention. Basically, there is no agreeable restricted domain for secant and cosecant. For cotangent, actually, yes, they do have the restricted domain. The convention, they have convention for the restricted domain. Let me write it down. For cotangent x, the graphs looks like this. This is the graph of cotangent. Okay, it's periodical. Okay, it's periodical. Okay, now they choose this window. They choose the window from 0 to pi. Okay, that's the window they choose. Not including 0, not including pi. Okay, that's for cotangent. But for secant and cosecant, there's no convention for the restricted domain. Our textbook just show you one of the convention, one of the common restricted domain being used, but that's not convention. Okay, the textbook we use at West LA College shows two different ways to do the restricted domain. Okay, two different ways to do the restricted domain. But there is no convention for that. Okay, there's no convention for that. Therefore, you will see we will not be able to compute secant inverse, cosecant inverse if they are negative numbers. If positive numbers, we use quadrant 1. Okay, we use quadrant 1. Later on, you will see the restricted domain always include quadrant 1. But then after that, do we use quadrant -1 if negative, or 2 if negative, or 3 if negative? We don't know. Okay, there's no restricted, there's no convention for the restricted domain when it comes to secant inverse, cosecant inverse, except when it's positive, which will give us quadrant 1. Okay. Now we will do problems. Now you will see I will do problems that requires that give us some variation toward the end. Okay, so I will do quite a lot of problems here. Okay, so number 1, I start from the easiest one. Okay, sine inverse of negative radical 2 over 2. Then it must be quadrant -1, right? Okay, it must be quadrant -1. It's negative, the reference angle pi over 4. Part B, how about cosine inverse of -1/2? It must be quadrant 2. The reference angle pi over 3. So 2 pi over 3. If you know the answer is 2 pi over 3, go ahead. Just do it. Just do 2 pi over 3. You don't need to write pi minus pi over 3. C, what is tangent inverse of negative radical 3? Well, that must be -1, right? Quadrant -1, negative 60 degrees, negative pi over 3. That's number 1. Number 3, besides writing it as cosine inverse, another way, or sine inverse, another way to write sine inverse is arc sine. Now, this notation has exactly the same meaning with sine inverse. Okay, It has exactly the same meaning. It's just an older notation. So in the past, they write that as arc sine. Okay, now they write it as sine inverse. Arc cosine of radical 2 over 2 is cosine inverse of radical 2 over 2, that's pi over 4. Tangent inverse of -1. Tangent what give us 1? Pi over 4. But this must be negative, right? So negative pi over 4. Okay, number 5. Part A, what is sine inverse of pi over 3? Now, this is not sine pi over 3, which is radical 3 over 2. Okay, this is sine what give you pi over 3. But pi over 3 is greater than 1. Right? Pi over 3 is greater than 1. So there's no such angle. There's no such angle. Undefined. Okay? Yeah, pi over 3 is more than 1. There's no angle such that sine of that angle is greater than 1. Part B, likewise. How about cosine inverse of pi over 2? Pi over 2 is more than 1. There's no such angle. Okay. How about tangent inverse of 1? Well, we have something like that. That is pi over 4. Okay. The range for sine, just to remind us, let me use red color. Range for y equals to sine x is -1 to 1. Okay. So the domain for inverse sine is also that -1 to 1. Remember, the range for the function is the domain for the inverse function. Okay. In other words, you can only plug in a number between -1 to 1 for sine inverse in the argument. Okay. Likewise for cosine. Now, tangent, however, has the range all real numbers. Okay, therefore, the domain of the inverse tangent is also all real numbers. Okay, now number 7. Number 7, part A. What is sine of arc sine of -3/10? Okay, our textbook does it this way. The way our textbook think is sine and arc sine, sine and arc sine are inverses to each other. So sine of arc sine of x is equals to x. Okay, that's the way our textbook thinks. Okay, of course, they are correct too when they say as long as x is between -1 to 1. Okay, but it's kind of hard to memorize, to remember it this way though. You can think of it that way. The sine cancels arc sines. So the answer here will be negative 3/10. Okay, but sometimes what happens is we do it so fast such that we don't pay attention to restricted domain. Okay, negative 3/10 is between negative 1 to 1. So yes, you can do that. But what happens if I change the question to sine of arc sine of negative 10 over 3? Now that is not negative 10 over 3. It is not. Why? Negative 10 over 3 is not even in the domain of arc sine. Okay, no, so they don't cancel. Maybe I use another example. Sine of arc sine of 2. This is not equals to 2. No, it's not. Why? Because arc sine of 2 is undefined. Okay, 2 is not in the domain of arc sine. Okay, now instead of doing it by memorization with our textbook, I offer you another method, which is actually quite useful for other setting later on. Okay, it's a bit longer, but you will, once you get used to it, then you can do it a lot faster. Okay, my method, which is not my method, call that alternative way, in which we basically slow down a bit. We basically slow down a bit and try to figure out if it is okay to have such thing. Okay, now the way I do it will be, I will call this an angle first. I will call this an angle. Let theta equals to sine inverse of negative 3/10. So sine theta equals to negative 3/10. Is it right? Now, is negative 3/10 in the range of sine? Yes, it is in the range of sine, right? This is in between negative 1 to 1. Okay. Now, so sine of theta, which is sine inverse of negative 3/10, is negative 3/10. How do you get that, Thomas? You substitute the theta. You substitute the theta. The theta equals to sine inverse of negative 3/10. Okay, pictorially, what I did was this. Okay, sine theta equals to negative 3/10. Because it is negative, I don't want to attack negative angle, negative value. I don't want to attack that directly. I use the reference angle. Okay, sine theta hat will be 3/10. Okay, and this will be in quadrant negative 1. So what is sine of an angle in quadrant negative 1? That will be negative value. Now, the reason I show you this because of the method that I will show you later on for other type of questions. So part B, let's do part B first. What is cosine of arc plus cosine of 1/2? Now you can say, well, cosine and arc cosine cancels, and 1/2 is in the restricted domain. So this is equals to 1/2. Okay, you can say it that way. You can say it that way. Okay, now, or alternatively, I call that arc cosine of 1/2 an angle theta first. Let theta equals to arc cosine of 1/2. So cosine theta is 1/2. I can draw the triangle. If this is theta 1/2, right? So this is radical 3. Okay, now what is cosine theta? Now notice that theta is arc cosine of 1/2, right? So cosine of arc cosine of 1/2 is 1/2. So I already answered that question. But do you notice that at the same time, we found a technique to answer the following question? So what if I ask you what is sine of arc cosine of 1/2? Now, if you call that arc cosine of 1/2 as theta, then you get that right triangle. So sine theta will be radical 3/2. Okay. In other words, sine of arc cosine of 1/2 is radical 3/2. Now we will see this later. Okay, we will see this later. Just be very careful that don't just think. The reason I should give you this alternative method is because then we can answer other type of question later on using this technique. Okay, but especially because I need you to be careful with the restricted domain. Okay, I need you to be careful with the restricted domain. Now, part C, tangent of arc tangent of 14. There is no restricted domain for arc tangent. The restricted domain for tangent is from -pi/2 to pi/2, right, for tangent. But the range is not restricted. The range is still all real numbers. So tangent of arc tangent of 14, they will perfectly cancel each other. Okay, but if you slow down, if we slow down a little bit, alternatively, we say let theta equals to tangent inverse of 14. So tangent theta equals to 14. Draw the right triangle. If this is theta, this is 14, this is 1. Okay, now then the tangent of that theta, which is tangent of tangent inverse of 14, is 14. Now, how about number 9? Now, later on, when you do suggested homework, you still do odd numbers that I already go over, right? Then you can be more careful when you do this. Okay, sine inverse of sine pi/3. According to textbook, again, sine inverse and sine cancel, so this must be pi/3. Okay, but the sine has to be in the angle has to be in the restricted domain. Okay, in other words, the following is not true. Sine inverse of sine 2 pi over 3 is not 2 pi over 3. No, it's not. Okay, in fact, that is equals to pi over 3. Why? Sine inverse of sine 2 pi over 3 is equal to sine inverse of radical 3 over 2, right? Sine 2 pi over 3 is radical 3 over 2. Now, but sine inverse of positive number must be in quadrant 1. That's the one I need you to be careful. Okay, so even though sine inverse and sine, they cancel each other, there is some restriction in the domain that you need to be aware of. So for this type of question, it's better for you to just do it inside out. Okay, it's better for you to just do it inside out. Let's say, for example, this is number 9a, right? I jump to number 11a. I jump to 11a. So you see that we have sine inverse of sine 5 pi over 4. You see 5 pi over 4 is not in the restricted domain for sine. So this question will not give you 5 pi over 4. No, it's not. Now, but it is easier actually for us to just do it one by one. Now, sine 5 pi over 4, that's quadrant 3. Okay, reference angle pi over 4. So that is negative radical 2 over 2. But this is negative the reference angle pi over 4. Negative pi over 4. Okay, compare with that. It's not true. Okay, it's not true. Of course, I have to admit there's another way to do that, but I will not share with you that method on the first day you see this inverse trick. Okay, you can think this way. You can think of it this way. Well, okay, what is the reference angle for pi over 4? 5 pi over 4. What's the reference angle for 5 pi over 4? Is it because, yes, because of the restricted domain. That's right. Yeah. What is the reference angle for 5 pi over 4? Okay, that's pi over 4. That's the reference angle. Now, sine is positive or negative? It's negative. So then somebody say, oh, if so, you use the reference angle, okay, and the fact that it is in quadrant 3, then it will be negative. Okay, but to do it that way, there are too many things to memorize. Too many things to memorize to do it that way. Okay, so I still, if you ask me how will I do it, will I do this problem myself in a secret, like if I don't need to show anybody what I do, this is how I do it. I basically do it inside out. Okay, number 11c. How about arc tangent of tangent 7 pi over 4? Now the answer is not 7 pi over 4. Even though you say, oh, tangent and arctangent, they're supposed to cancel each other. That's true, but there's a restriction in the domain. Okay, so the phrase restricted domain is something you need to be aware all the time. When I start taught pre-calculus, so I usually teach trigonometry. So I have no issue when I introduce trigonometry, this inverse trick to trigonometry student first time, okay, at West LA College. But in Santa Monica, because the pre-calculus class does not have trigonometry as prerequisite. So by the time we get into these inverse trick functions, students are pretty good with their algebra already. but they are so good that they can skip so many steps without paying attention to the restricted domain. Now, what I did in the past was this. Imagine this is my whiteboard in class, okay? I purposely write something right in the middle here. It's like a button called restricted domain. So when we do problems, okay, when students give me wrong answer, I point at this. I point at this. Every time students give me wrong answer, I point at this. I point at this. In other words, if they make mistake, it must be because they forget the restricted domain. As if that's a button, as if that's the button that I will press every time a student give me wrong answer. And most of the time, not all the time, but most of the time, the wrong answer is caused by restricted domain. Okay, by this point, week number 13, most students already really good with their special trigonometric values, right? Okay, so they can do that mentally already, and I do expect that from you. Okay, but the thing is, they could do it so fast, but they forget the restricted domain. So at this point for you, okay, very likely if you make any mistake, it's because of restricted domain, restricted domain, restricted domain. How many times do I have to say it so that we remember? Okay, so instead of pointing at what is the right answer only, in this case, by the way, that's what I usually do. I point at the right direction, right? Okay, but instead of doing it this time, I point out things that you need to pay attention. What are the common mistakes? Okay, so again, pre-calculus students at this point, they will see, oh, tangent inverse and tangent cancel, so this should be 7 pi over 4. Okay, but no, that's not true. That's not true. Okay, it is true that tangent and tangent inverse cancels each other as long as they are in the restricted domain. But if not, then you need to slow down. Okay, now what is tangent of 7 pi over 4? Tangent of 7 pi over 4, 7 pi over 4 is quadrant 4, where tangent is negative. This is negative 1. Okay, now what is tangent inverse of negative 1? That's negative pi over 4. Okay, now let's go on. I will do a couple more problems. Number 13, part A. What is sine of cosine inverse of negative 1/2? Can I use negative pi over 4 with unit circle? What do you mean by can I use? The answer is negative pi over 4. You can, if you can understand that better, go ahead. Yeah, if you can understand that better using another method, go ahead. What I don't want to happen is because your understanding is the way you get it is different from me, and it becomes an obstacle when for my later material. Like for example, this one here, sine or cosine inverse of negative 1/2. Okay, how do we do that? Okay, so I will say let theta equals to cosine inverse of negative 1/2. So cosine theta equals to negative 1/2. Okay, now cosine inverse of negative 1/2, it must be in quadrant 2. Right? Okay, it must be in quadrant 2. Now, cosine theta equals to negative 1/2, I can draw the triangle using reference angle. This is 1, this is 2, this is radical 3. Okay, now what is sine theta? sine theta will be plus or minus radical 3 over 2, right? Look at this triangle here. So sine theta hat will be radical 3 over 2, is it right? But it is in quadrant 2. Theta is in quadrant 2, so sine theta is radical 3 over 2 also. Okay. But we are basically done with the question. I just need to rewrite it. So sine theta, which is cosine inverse of negative 1/2, is radical 3 over 2. Let's try number 15a. Number 15a, I jump around because I want you to do some problems after the break. Number 15a, how about cotangent of sine inverse of 2/3? So we let theta equals to sine inverse of 2/3. So sine theta equals to 2/3, that's quadrant 1, right? So I can go ahead with the right triangle. If this is theta, this is 2, this is 3. So this will be square root of 5, right? 9 minus 4. Now what is cotangent of theta? Cotangent of theta is square root of 5 over 2. Now why do we want cotangent of theta? Because theta is sine inverse of 2/3. Okay, now I would like you to do 13b. Number 13b, what is cosine of tangent inverse of 1? That's 13b. And also 15b, secant of tangent inverse of negative 3/5. And 15c, what is cosecant of cosine inverse of negative 1/4. Okay, now I want you to do these 3 problems. It will take you approximately 5 minutes in total, plus 10 minutes break. We come back at 9:45. So 9:45, we are done with these 3 questions. Okay, I will start. So tangent theta equals to 1. You can actually say tangent theta, tangent inverse of 1 is pi over 4 from there. You can. Yeah, I just try to show you the procedure if that were not happen to be a special trig value. Okay, then we resort to the following method. So this is tangent theta equals to 1. That's in quadrant 1. So I can go ahead with that right triangle. That's 1 over 1. This is square root of 2. Now the cosine of that theta is 1 over radical 2. So to be more explicit, cosine of tangent inverse of 1 is 1 over radical 2 or radical 2 over 2. (15b) secant of tangent inverse of negative 3/5. Let theta be tangent inverse of negative 3/5. Tangent inverse negative, that's in quadrant negative 1. Or you can call that quadrant 4. Okay, so tangent theta equals to negative 3/5. The reference angle is 3/5. 3, 5. That will be square root of 9 plus 25, 34. Okay, now secant of theta hat is square root of 34 over 5. And theta is in quadrant -1. So secant is still positive, right? The reciprocal of cosine. So to be more explicit, secant of tangent inverse of -3/5 is radical 34 over 5. (15c) let theta be cosine inverse of -1/4. Now, because cosine inverse of negative, it must be in quadrant 2. So cosine theta equals to -1/4 reference angle, so that we can get the right triangle. That's 1/4. That's 1/4. This is square root of 15 then, huh? Now then, cosecant of theta hat will be 4 over radical 15. But theta is in quadrant 2, where sine is positive, and therefore cosecant also positive, 4 over square root of 15. To be more explicit, cosecant of cosine inverse of -1/4 is 4 over square root of 15. Rationalize the denominator. Okay. Now, let's go on to a slightly more complicated one. Let's say, for example, number 17c. Tangent of tangent inverse of 4/3 plus cosine inverse of 8 over 17. We will let, let's say, angle A be tangent inverse of 4/3. Angle B be cosine inverse of 8 over 17. Now, with this substitution, we basically need to compute tangent of A plus B, right? That's what we need to compute. Okay, now tangent A plus B will be tangent A plus tangent B over 1 minus tangent A tangent B. So we need tangents for A and B. Oh, this one is nice. Tangent A equals to 4/3. I don't even need to draw the triangle, right? Because I already have tangent A. Now, how about B? Cosine B is 8 over 17. That's in quadrant 1, so I can draw the right triangle right away. So if this is B, this is 8, 17. Then by Pythagorean triple, this is 15. So tangent B will be 15 over 8. Is it right? Okay, so then I continue. So tangent A, tangent B, tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A, tangent B. That's 4 over 3 plus 15 over 8, big over 1 minus 4/3 times 15/8. Multiply the top and the bottom by the LCD 24. I will get, that's 32 plus 45 over 24 minus 60. That's 77 over negative 36. Okay, so to summarize, so tangent of tangent inverse of 4/3 plus cosine inverse of 8/17 is equals to negative 77 over 36. Okay, in fact, I want to go on a bit further. Okay, I want to go on a bit further. This is the type of question you don't see in the textbook, but you see in my test. Okay, let me go on. Which quadrant is tangent inverse 4/3 plus cosine inverse 8/17 located? Can you tell which quadrant it is? Okay, now the solution will be as the following. Now tangent inverse 4/3, we call that A. That's must be in quadrant 1, right? Okay, because tangent inverse positive is in quadrant 1. Now cosine inverse of positive also in quadrant 1. That's also in quadrant 1. In other words, A is between 0 to pi over 2. B is also from 0 to pi over 2. When we add, A plus B must be between 0 to pi. In other words, A plus B must be in quadrant 1 or quadrant 2. Okay, but tangent of A plus B is negative, which means A plus B is either in quadrant 2 or quadrant 4. So from the sum of the angles, it is either in 1 or 2. From the tangent of the angle, is quadrant 2 or quadrant 4. So the conclusion, A plus B must be in quadrant 2. You see that? Remember I told you before that how do we know an angle is in which quadrant, and put it under sine, cosine, tangent, two of them. Now in this case, we know the tangent, the value of the tangent of this angle is negative. So it's either 2 or 4, right? Now at the same time, from each one of them, A and B, when we add them, it gives us two possible quadrants, 1 or 2. So which quadrant it has to be? If it has to be in here or and also in here, then it must be in quadrant 2, right? Okay, now it's like my last name. My last name, by the way. I usually don't like to talk about my last name. Okay, some students call me Harjuno, and they were not kidding. No, they give me that nickname Hard. It's because they think I'm hard. But anyway, some people when they read this name, they have in mind either Thomas is an Indian, because the name Harjuno actually coming from Mahabharata story. Mahabharata. Okay, now Mahabharata story is very well known in India and also in Indonesia. Okay, now then somebody say, Thomas, your last name also have the feeling of Japanese last name. Now using this, either Indian or Indonesian, or from Japan or Indonesia, then from there people decide, oh, then he must be from Indonesia. Okay, if you happen to know that Harjuno, that word comes from the name of a character in Mahabharata story, people with Hindu background will know this, even though my dad, when he chose this last name, when he changed his citizenship, he likes that character, not because of the Hindu background, not because of the Indian background, but it is because of what that character does in the story. Okay, now it happens that this name, this way of writing, makes some people think, especially if that person is Chinese. If that person is Chinese and they read this name, they have a tendency to think I'm Japanese. Okay. They have a tendency to think I'm Japanese. Some people even at one point thought that, oh, I don't really, I have this comment before. So some people say, I don't really read this last name with from Latin America. I say, if you see me, I'm not from Latin America. No offense, okay? Yeah, but the person who read my name, they read Harjuno. When I went to Marine, my drill instructor read my name as Harjuno, and then once he saw my face, it's like, no, how to pronounce your last name? It's definitely not Harjuno. You're Asian. You're not Latin American. I say it's Harjuno, and then they actually teased me when I was in Marine. How'd you know? How'd you know? It's like, how'd you know what? How'd you know? How'd you know my last name? You just read it there. No, how'd you know? Right? That's how you read that. How'd you know? It's like a question. My last name is a question. How'd you know? Okay, well, anyway, so that's how we actually find out where this angle is located. Okay, now let's go on further. Using this technique, we go on with, for example, number 19. Number 19, part A, sine of 2 times cosine inverse of negative 24 over 25. How do we attack that? Use this as our angle. So we will end up computing sine of 2 theta. Okay. So let theta equals to cosine inverse of negative 24 over 25. Now we know this is in quadrant 2 because cosine inverse of negative must be in quadrant 2. And then cosine theta, therefore, is negative 24 over 25. Now let's see first what do we need. Sine 2 theta is 2 sine theta cosine theta. We already have the cosine theta. We need sine theta. Get the reference angle so that we can draw the right triangle. This is theta head. This is 24, 25. By Pythagorean triple, that's 7. So sine theta head is 7 over 25. But theta is in quadrant 2 where sine is still positive. Okay, now that's the setup, right? Now using that, then let me continue with the formal work. So sine of 2 cosine inverse of negative 24 over 25 by substitution is sine 2 theta, which is 2 sine theta cosine theta. And according to what we have there, sine theta is 7 over 25. Cosine theta is negative 24 over 25. That's 2 times 7 times 24, and that's negative. That's negative. What is 14 times 24? 336 over 625. Okay, and then I still can ask you this question. Can you argue without using calculator, of course, which quadrant is 2 cosine inverse of negative 24 over 25 located? Now we know that cosine inverse of negative 24 over 25 is in quadrant 2, right? We called that theta earlier. So theta is between pi over 2 to pi. Now, then when I double it to theta, then it must be between pi and 2 pi, right? In other words, 2 theta is in quadrant 3 or quadrant 4. Now, unfortunately, sine of 2 theta, that's negative, which gives us the same result. 2 theta is either in quadrant 3 or quadrant 4. So we cannot decide using what we have there. Then apply cosine 2 theta. Or you can use tangent 2 theta also. Okay, but let me use cosine 2 theta. Cosine 2 theta will be 2 cosine squared theta minus 1. I use cosine because that's what we have, right? This is 2 times negative 24 over 25 squared minus 1. So that's 2 times 576 over 625 minus 625 over 625. That is positive. It's positive, sorry. Positive greater than 0. So from there, we know that 2 theta is either in quadrant 1 or quadrant 4. Now, then together, this guy, which gives us the same result with that, together with this guy, then so 2 times cosine inverse of negative 24 over 25 is in quadrant 4. Now, let's deal with this in more general setting. For example, let's take a look on how about number 31? Number 31. For x positive, okay, expressed in terms of x, tangent of 2 cosine inverse of 1 over x. Express that in terms of x. Actually, we do exactly the same thing. Okay, we do exactly the same thing. Nothing really changed. Instead of using real numbers, we now use variables, right? Let theta equals to cosine inverse of 1 over x. And because x is positive, then theta must be in quadrant 1. Okay, cosine theta equals to 1 over x. Draw the right triangle. 1 over x, so this is square root of x squared minus 1. Okay, now tangent 2 cosine inverse of 1 over x using that substitution is equal to tangent 2 theta, which is 2 tangent theta over 1 minus tangent squared theta. 2 square root of x squared minus 1 over 1 minus x squared minus 1. That is 2 square root of x squared minus 1 over 2 minus x squared. Okay, that's for number 31. I think that's all for this section. Yeah, that's all for this section. You should try up to number 33 suggested homework from 6.6. Work on number 1 to number 21. Just do every other odd. Number 23 to number 33, do the odd ones. I think those are important. And then try to use what we learned earlier to solve equations. Let's say, for example, I pick number 69. Number 69, we have cosine x times 15 cosine x plus 4 equals to 3. Solve. So I distribute 15 cosine squared x plus 4 cosine x minus 3 equals to 0. I don't think this is factorable, is it? Let me see. Look at the discriminant. B squared minus 4AC. That's 16 plus 6180. 196. Oh, that's a square number. Yes, it's factorable. It's factorable. So let me try 5 cosine x with 3 cosine x plus 3 minus 1 equals to 0. So cosine x equals to negative 3/5. Cosine x equals to 1/3. Okay, now then from here we see, now do not say that x equals to cosine inverse of negative 3/5. Don't say it that way. Why? Because then you will get only one answer here. It will be only quadrant 2. But we know there are two solutions in the first interval from 0 to 2 pi. There are two solutions for this, right? So it is not correct to say x equals that. Okay, it is not correct to say that. Okay, it is okay to say that's one of the solution. So let me use subscript there. Okay, even though I prefer to do the following. Cosine x hat equals to 3/5. I deal with the reference angle. So this is the reference angle of the solution. And you can use calculator for that. Let me use calculator. And make sure the mode is in radian though. Okay, so cosine inverse of 0.6 is, so x hat, the reference angle, is 0.92730. That's the reference angle. But cosine is negative in quadrant 2 and quadrant 3. So in quadrant 2, there will be pi minus that number. In quadrant 3, it will be pi plus that number. You see what I mean? So I use reference angle and then change it back to quadrant 2 and quadrant 3. Okay, now cosine x equals to 1/3. It's already positive, right? So x hat will be, talk about the reference angle. X hat will be cosine inverse of 1/3. Using my calculator, I get x hat equals to 1.23096. Then in quadrant 1, that will be the same answer, right? Because cosine positive in quadrant 1 and quadrant 4. That's one of the answer, quadrant 1. And the one in quadrant 4 will be 2 pi minus that angle. Okay, now of course then you use calculator to compute them. Okay, that's how we use inverse. Now do not use inverse cosine or inverse sine or inverse tangent when the argument is negative. If that's the case, you better attack that from the reference angle. Okay, you attack that from the reference angle. That's for number 69. Okay, I still have approximately 40 minutes. Okay, let's go on to 7.1. A new section, 7.1, Law of Sine. Yeah, today I'm supposed to finish 7.1 according to my schedule. I don't think I can finish it. but at least I can do most of it. Okay, law of sines, I still want to prove that. Suppose I have side A, therefore this, an angle A, therefore the opposite is side A. Let's say this is angle B, so the opposite is side B. This is angle C, so this is side C. Okay, there are many ways to prove law of sines. One of the way is by looking at the area. I somehow thought I already showed you the area of a triangle. Okay, area of this triangle is equals to 1/2 the product of two sides times the sine of the included angle. Okay. But we can also write it in other variation, 1/2 AC sine angle B, that's the included angle, 1/2 AB sine of the included angle C. Now multiply all of these by 2 divided by ABC. Yeah, multiply by 2 will cancel all the 1/2. Dividing by ABC will give us sine A over A equals to sine B over B equals to sine C over C. Now the thing is, have I in the past went over to prove this formula? Did I do that? You have to memorize that though, okay? If I never go over that before, then I can show you the proof how to get that. But then from now on, you still have to memorize that. Okay, now let's see. Okay, how do we prove that? If I draw the altitude from C, this will be the height, right? Okay, so this I'm proving this blue one. So the area of this triangle is equals to 1/2 the height times C. But at the same time, we know that sine A equals to height over B. So the height is B sine A. Now substitute that back in. The area of a triangle equals to 1/2 B sine A times C, or 1/2 BC sine A. Okay, 1/2 of the product of two sides times the sine of the included angle. That's how we get this formula here. Okay, now the rest are actually the permutation of the variables that we use. BCA, ABC, ACB thingy. Then from there, we multiply by 2 to get rid of the 1/2 and divide by ABC to have this ratio. Okay, another way to prove this is by looking at that triangle that I draw, another proof, the second proof. Look at that height. Look at that height. Notice that sine A equals to the height over B, right? Okay. At the same time, sine B is equals to the height over A. So the height is B times sine A. But at the same time, from the second ratio there, we see that the height is also A sine B. Now divide by AB, give us what we need. Okay, now that's the law of sine. That's the law of sine. Now, definition. A triangle consists of 6 parts. Six components. Angle A, angle B, angle C, side A, side B, side C. Those are the 6 components. Now, when we say to solve a triangle, is to find the values of these 6 components. You need to find 3 angles and 3 sides. Now, of course, most of the time, no, actually all the time, to solve a triangle, they will give you 3 components and you need to look for the other 3 components. Okay? Now, when do we use law of sines? When we have a pair that is an angle and its opposite side. Okay, so either you have this pair or this pair or this pair. If you have a pair, then you can use law of sine. Okay. Now let's see. Now we do problems. I'm done with this section actually. It's just doing problems from now. Okay, let's say for example we do. Oops. Hold on. This is 10:25 already. Then I will continue on. I somehow thought that I end at 10:55. Wow. Okay, so I will continue on Thursday on law of sine, but we already proved that, right? So on Thursday we will do 7.1, 7.2, and 9, not 9, is it 9? And 9.2. Okay, so please read, not 9.2, 9.1. Please read 9.1. Please read on Thursday. We will do continue with 7.1, finish up 7.2, and then 9.1. Okay, that's what we'll do on Thursday. I skipped chapter 8. We will not do chapter 8. Yeah, we will not do chapter 8. Let me see again. Yeah, if I have some time, then I will do, let me see it again. If I have extra time, then I will do the chapter 10. Yeah, that's what I plan to do. Okay, but we will not do chapter 8. Okay, we will not do chapter 8. Okay, see you then on Thursday. Okay, let me stop recording first.